Hello everyone, welcome to Miss Lee's class. Today we're going to learn how to use function notation. So what's the function notation? So it's a simpler method of representing a function. So we're going to learn how to use a function notation, okay? So last class we learned a function is an input-output machine. So the input is the domain and the output is the range. So for example, if you plug 3 into the function machine, it follows the rule. The rule is square the input. So if you plug 3, the function machine square the input and it becomes 3 squared, which is 9. Okay? So in the function machine, you look at this. So here, function machine. The name of the function machine is f in this case. So this is called function notation. F of x equals x squared. So basically, I want you to write it down. F of x equals x squared. If you plug 1 into the function machine, so this is the function machine. If you plug 1 into the function machine, you write it here. Right below this, you write it, oh, this is the rule, this is the function machine, and right below it, you say f. If you plug 1 into the machine, and you have to square it, which is 1. Okay? So this is the output, and input goes to the bracket. So basically, f of input, and it gives out the output. As you know, input is the domain and output is the range. Okay, let's use other number. If I plug 2 into this function, okay? If you plug 2 into this function, what do you get? 2 squared, which is 4. So this is the input and this is the output. Okay? So in this case, it plugs 3 into the machine. You got 9. Next one. This one, the name of the function is g in this case. And the rule is adding 1, x plus 1. Okay, if you plug 3 into the g machine, function machine, 3 plus 1 equals 4. So g of 3 equals 4. Let's use other number. So we know g machine is x plus 1. Okay, so let's plug 1, not f. Let's plug 1 into g of x. G of 1. So you use this rule this time. Okay? 2. Let's plug 2. 3. 2 plus 1 equals 3. If you plug 3, you get 4. If you plug 4, you get 5. Okay, so depending on how you define the function, the output value will change. Okay, remember, you plug input into the bracket, and depending on the rule, you're gonna get different outputs. Make sense, everyone? Okay, let's move on. Let's look at the warm-up question. So define your own function and find the range. Define your own function and domain. When you define your function, you have to define your domain too. So this time, for domain, I'm going to use all real number. So do you remember what all real numbers are? So we learned it in 5.4. Real numbers are just basically all the numbers. Natural number, whole number, integer, rational number, and irrational numbers. All the numbers you know are real numbers. So we are going to use all real numbers. I want you to focus on the notation. Domain. For domain, we usually use x, and for range, we use y. And we're going to use a set notation, x bar. X bar means elements of the set are X values. Okay, X bar. X is all real number. Remember this notation. So this is a real number set. So you use double line for R. Okay, this is a real. This means a real number, all real numbers, and this means X is in all real numbers. So meaning is X is all real numbers. So remember the meaning, and you're going to use this notation again and again. So memorize, remember this notation. So we just defined our domain, and now we're going to use a function machine. We're going to define our function. So the name of the function can be any alphabet. So let's just use, you can use F or G, but this time I'm going to use Z. So we have Z function, okay? And let's define the rule. So my function is Z of X equals X plus 10, okay? So this is my definition of my function. So you can use other alphabet and use other rule. Okay. So this is my function. Okay. Now we're going to use input value to find output value. Okay. So let's starting from, I don't know, like 0. Let's start from 0. Then what's going to be the output? Z of 0 equals 10. Let's do 1. Then Z of 1 equals 1 plus 10, which is 11. Z of 2, let's plug 2. 2 plus 10, 12. Or Z of negative 10. What is negative 10 plus 10? Which is 0. Okay then, everyone, what is the minimum Y value and maximum Y value? So depending on input, Y value changes, right? The output value changes. So what's going to be the minimum output? Well, I think the minimum output value should be negative infinity, and the maximum value will be positive infinity. So if you plug, say you plug negative infinity into the machine, it becomes negative infinity, right? Negative infinity plus 1, it's still negative infinity, right? And if you plug infinity into X, it's infinity plus 10. It's just an infinity, right? Infinity plus 10 is just infinity. So therefore, the range of Y range is, the range will be from negative infinity to positive infinity. Basically, all real number. So we say Y bar, Y is also all real number. Okay? So this is how you define your own function, define domain, and find the range. Okay, a function notation is a simpler method of representing this diagram. If we just use equation, it will be Y equals X plus 10. Then if we want to find the value when X is 1, we have to write like this. Y value when X is 1 is 1 plus 10, which is 11. So notation is not really simple, right? If we want to find Y value when X is 5, you have to write it like this. 5 plus 10 and equals 15. The notation looks complicated, but if you use function notation, so you have to define the function rule first. So it was Z of X equals X plus 10. So if you want to know Y value, output value when X is 1, then you just plug 1 into the bracket. This is the input, so 1 into the bracket, and the output will be 11. Z2, z of 2 will be 12, and z of 5 will be 15. Much simpler, okay? So we use function notation in this chapter, so you should be aware of how to use function notations. Okay, let's move on. Function notation summary. F is the name of the function. It can be z or it can be g. So this is the name of the function, and this tells you that x is the input. So you plug input into the bracket, and this is a rule for the function machine. Okay, tells you what function does. So this function multiplies the input value by 2. So you start from the function notation, the rule, and if you want to find the output value when x is 2, f of 2. F of 2 is 2 times 2, right? So it becomes 4. F of 5. 5 times 2 becomes 10. So this is how you represent input and output values using the function notation. Okay, let's look at example 1. Here is a graph of the function f of x equals negative 3x plus 7. X is all real number. Remember, this is all real number. Determine the range value when the domain value is negative 2. So domain value, input, the range value, output. So we're going to find the output when input is negative 2. So let's plug negative 2 into the function machine. F of negative 2 equals negative 3 times negative 2 plus 7. Negative 3 times negative 2 is 6 plus 7 is 13. So the domain value, when domain value is negative 2, the range value becomes 13. Determine the domain value when the range value is 4. Okay, f of x, we know f of x equals negative 3x plus 7. Okay, so we want to know x is the domain value, when the range value, so range is basically the whole thing, okay? So when the range, the output, when the range is 4. Okay, so this is the function rule. After putting a number into the function, the result should be 4, right? So if the question asks you to find the range value, you substitute the whole f of x with the range value. Okay, so there was f of x, you substitute the whole thing with 4. If it is x value, input value, if you have input value, just simply plug in the number into the bracket. But if it's a range value, you substitute the whole f of x with the range value. Make sense? Now we're going to solve it. Isolate x by subtracting 7. Subtracting 7. Then negative 3 equals negative 3x. And let's divide both sides by negative 3. Negative 3. Then x equals positive 1. Okay. So when f is 1 and x is 1, when x is 1, the range value becomes 4. Let's check it by doing it. So we know f of x equals negative 3x plus 7. So let's plug 1 into x, then that becomes negative 3 times 1 plus 7, then that becomes 4. So it's a correct answer. Okay? Find the value of f of x plus f of negative x. So we know f of x equals negative 3x plus 7. F of negative x, you plug negative x into x. Okay? So that means you plug here negative x into x. Then what happens is negative 3 times negative x plus 7. Okay, let's calculate this. So negative 3x plus 7 plus negative 3 times negative 5 becomes positive 3x plus 7. Okay, then negative 3x will be cancelled. 7 plus 7 becomes 14. So if you calculate this, the answer will be 14. Okay? So what's important here? So when a function is given, f of x, negative 3x plus 7, if the input value is given, let's say the input is 5, you find f of 5. You plug x into 5 into x. If the output is given, so output is given, say output is 10, then you substitute the whole f of x with 10. So it becomes 10 equals negative 3x plus 7. So you should be able to figure out the difference. You have to understand the difference and find the answer. Okay? Example 2. The equation V equals negative 0.08D plus 50 represent the volume, V liters of gas remaining in a vehicle's tank. After traveling D kilometers, the gas tank is not refilled until it's empty. Describe the function. Write the equation in function notation. So the function, this is the equation, but we're going to change this to a function notation. You're using D here, so we have to say, so we're going to use V as a function name, and the variable will be D, negative 0.08D plus 50. So this is the function notation. Determine the value of V 600. So the input is 600, right? So V 600. V 600 means the input is 600. So we're going to plug 600 into D. Okay? Plug 600 into D. Remember, multiplication sign is hiding here. Plus 50. Then let's use a calculator to find the answer. Negative 0.08 times 600 is negative 48 plus 50. What's negative 48 plus 50? Which is 2. So the answer is, the remaining gas is 2 liter. 2 liter. Okay, V of D equals 26. The whole thing is 26. That means the output is 26. So 26, V of D is 26. We substitute V of D, the whole thing, with 26. Okay? So 26 equals negative 0.08D plus 50. And now we're going to isolate D by subtracting 50, then 24 equals negative 0.08D, and let's divide both sides by negative 0.08. And D equals 24 divided by 0.08. If you calculate it using your calculator, D is 300. Okay, so D is 300, and this D represent the kilometer. So if you go 300 kilometer, the leftover gas will be 26 liter. Okay, so let's just write it verbally. Here for B, after driving 600 kilometer, 2 liter of gas will be left in the tank. And this one, after driving 300 kilometer, 26 liter of gas will be left over. 26 liter of gas left over in the tank. Okay? Alright. Let's move on. Example 3. Find f of 1, f of negative 5, f of 7. Okay, here. F of 1. The input is 1. So input is x value. When x value is 1, so remember, input is x value. When x value is 1, what is the y value? 1. The output is y value, right? The output is 1. So f of 1 equals 1. What about f of negative 5? F of negative 5. Positive 1. A positive 4. What about f of 7? F of 7 is positive 5. Okay? And find x when f of x is 1 and f of x equals 6. The output is 1. F of x is the output. The output is 1 and the output is 6. So when the output is 1, so the output y value is 1. There are multiple x values, right? When f of x is 1, x value is 1, x value is negative 2, and x value is negative 8. Okay? So f of x equals 1, then x value will be 1, negative 2, and negative 8. When f of x equals 6, so I want you to try it by yourself. When f of x is 6, what is x value? Here, 6. And draw a line, horizontal line, and the x value is 8. So x equals 8. Okay, state the y-intercept using a function notation. So this is the y-intercept. What's the coordinate? What's the ordered pair of this? That is 0, comma, 2. So using function notation, this is the input and this is the output. So if you plug 0 into the input as an input value, it should become 2. So y-intercept is f of 0 equals 2. Okay, everyone, that is it for today. So it might be complicated. You have to review again and again because it's the first concept you're learning in grade 10. Okay, you will be using function notation again and again in grade 11 and grade 12. So review what you learned today and start doing your homework. Thanks for watching, everyone. Bye-bye.